Welcome to qnawire.
Given this pulley system, the problem asks us what is the value of this applied force such that this system will stay in equilibrium. Given that there is an electrical force pointed vertically upwards above the small block. So this problem involves Newton's law of motion. To solve this problem, we have first to identify the individual forces acting on each masses. Let's start with the small mass. Assuming this is a small mass, the force acting on its body are the weight, its weight, the normal force, the electric force, the applied horizontal force, and the friction. Applying first law of motion, since what we are achieving is equilibrium, the sum of the forces on the vertical plane is equal to 0. And the forces on this plane are the normal force, the electrical force, and the weight. This is negative since it is opposite the normal force. Rearranging the equation becomes normal force is equals to the weight minus the electrical force. And we know that weight is equal to the mass multiplied by the acceleration from gravity, and given the electric force is equals to the charge Q multiplied by the electric field. Then this is our expression for the normal force. Now, for the horizontal plane, same with the vertical plane, the summation is equal to 0. The forces on this plane are I forgot to include also the tension force in this direction, tension of the string on the string. As such, the forces on this plane are the applied horizontal force, the tension force, which is negative of the applied force, and the friction, which is also negative of the applied force, since it's opposite. Rearranging the equation becomes applied force is equals to tension force plus the friction force. And friction is equal to the product of the coefficient multiplied by the normal force. We already obtained an expression for the normal force. We just have to insert it in this equation. Then applied force is equals to T plus mu multiplied by this quantity. Now, for the large block, assuming this is the large block, the forces acting its body is its weight, the normal force, the normal force of the smaller block, the tension of the string, and the friction due to the small block. According to the problem, the floor is smooth. As such, there is no friction between the floor and the large block. Now, the summation of forces on the horizontal plane also is equal to 0 since the body is in equilibrium. And the forces on this plane are the tension of the string and the friction force of the small block, which is negative since opposite the pole of the tension. Rearranging as such, tension is equals to the friction force of the small block, which is the product of the coefficient of friction multiplied by the normal force, which is this one. Inserting this into this equation, then mu is equal to this quantity. Now we have an expression for P, or the tension force. Let's use again our equation for the applied force and insert the value of T. Then applied force is equal to or simply this quantity.